All right, so before we dive headfirst into this lesson, let's review the lab that we saw the other day with the exterior angles theorem for a triangle. Reviewing the vocabulary, remember we took our triangle and just extended a side out, and that formed a new angle called an exterior angle found on the outside of the triangle. And then our remote interiors, like remote control, you control it from away from, or a remote island is away from everything. We come inside the triangle to these two angles that are away from this exterior angle. Those are the remote interior angles. All right, so let's take a look at our lab. We found that if we were given these two remote interior angles as well as this exterior angle, there was that important relationship that our two exterior angles together could be added up and they would equal exactly the same as the exterior angle. Again, we did that for several examples. You did one, I did one, your classmates, everybody did one. We all got the same result. Even though we had different triangles, we all got the same thing, that they always added up. Those remote interiors equaled the exterior. So if you needed a formula, you'd have exterior angle is equal to remote interior angle number 1 added to remote interior angle number 2. Now we're going to prove that logically with a formal proof, and then we're going to do some practice on that theorem. So let's take a look. Okay, so here's our theorem stated in our notes. Our job is to prove that this angle 3, that would be our exterior angle, is equal to angle 1 and angle 2. Notice they're down here away from angle 3 and inside the triangle, so that's going to be our remote interior angle and our other remote interior angle, if I can abbreviate those. And those are getting added together to equal that exterior angle. So let's give this proof a shot. We are given our triangle with the exterior angle number 3, and our remote interior angles numbers 2 and 1. And you'll notice that I labeled this angle, angle 4, and it's the neighbor. It's not remote interior, it's neighbor interior. So let's see what this does. Okay, we've started out with a given. It's already listed there for you. Let's just put our reason as given. Now let's look for relationships that we know. One thing that we do know is that angle 4 has a relationship to angle 3. We've seen this relationship a few times. Well, more than a few times. We've seen it a lot. We've worked with this since Unit 1. What relationship do 4 and 3 have? You guys see that as a linear pair? So let's write an equation. We know that the measure of angle 4, what do I get if I add it to the measure of angle 3? I get 180 degrees because that makes a linear pair in my picture. So let's make that justification. Linear pair. 4 and 3 add together to make 180. What else can we say? Let's go to our triangle. This is from just this last lesson. What do we know about the 3 angles that are inside our triangle? Angle 1, 2, and 4 in particular. Well, we learned that angle 1 added to angle 2, added to angle 4. Okay, what I just do, I just added all 3 angles of the triangle. What is the total of the 3 angles inside a triangle? We learned that that's 180 degrees also. So let's call that the triangle angle sum. That's our triangle angle sum theorem that we just proved in the last lesson. All right, well, we just set up 2 equations and they both equal 180. We have a property that tells us that if they both equal the same 180 total, then they equal each other. Now, this is going to be kind of long, so write small. What I'm going to say is my angle 4 plus my angle 3 on this equation, that equals the same thing as if I were to add all 3 of these angles together. Angle 1, angle 2, and angle 4. So let me squeeze those in. Angle 1 and angle 2 and angle 4. Because these 2 angles equal 180, and so did these 3 angles. They both have a 180 total, so I'm going to say they equal each other. That's the transitive property. Since they equal the same thing, they equal each other, our transitive property. Okay, look at it, guys. Look at it. Do you notice something about both sides of this equation? What do you see is on both sides? Hopefully you're seeing angle 4 sitting there on both sides. So if it's on both sides, can I take it away? Can I subtract it? I'm going to do the subtraction property and subtract angle 4 from this side. That'll just leave me the measure of angle 3. But if I do it from this side, I also have to subtract angle 4 from this side. So let's get rid of it over here too. And that'll just leave me angle 1 plus angle 2. exactly what I was trying to prove. There's my exterior angle, angle 3. Look up here. That's what I was trying to prove. So angle 3 is equal to angle 1 plus angle 2, the remote interiors. What did we just do to get from this line to this line? We lost angle 4 with the subtraction property. So that's our justification. And looks like we don't need to do anything with line 6 because we just proved it. So good for us. We did it shorter than 6 lines. Okay, let's practice this theorem with some examples. We've got some unknown angles. They've marked them with a question mark, so we have to find that angle. Well, notice that this is an exterior angle of our triangle formed by just extending the side. So if we just apply our theorem, let's go find our remote interior angles. Right here is one and right here is the other. They're away from that exterior angle and they're inside the triangle. So my exterior angle should just equal the sum of the two remote interiors. That means I can just add them together. 70 plus 25, so my answer is 95 degrees. That's my exterior angle. Now in this example, we see another, where's the exterior angle? That's this 106, that's my exterior. And let's go find the remote interior angles. This is one of them here, and this is one of them here. One of them is unknown. So in this case, if I'm going to use my theorem, I'm going to say my exterior angle equals my remote interior plus my other remote interior. But in this case, I don't know one of them. Instead, I know that's 106 total. 106 total has to come from the 64 degree angle plus the question mark angle. So the way you would do this is you say, okay, I got 106 total. I'm just going to take away the 64 and see how much is left over for the last angle, that second remote interior. So subtracting those, I'm getting 42 degrees. So 42 degrees is the second of the two remote interior angles. Right there. All right, now in number 3, something interesting is happening. You notice that they didn't extend just one side out. They extended 2 sides out. They're just trying to make the picture more complicated. But this 160 degree angle is an exterior angle. On the outside of that triangle, there's another exterior angle. We're just not going to use it because it doesn't have any information we were asked for. That 160 is exterior, and its remote interiors are way over here inside that triangle right there. Those two little babies right there have to add to 160. So if 160 needs to be their total, let me just take away the one that I do know, the 66 degree angle, and see what I have left over for that angle at D. All right, so subtracting this, I'm getting 94 degrees. No, that can't be right. Is that right? Yeah, it is right, 94 degrees. So that angle D up here, that is going to be a 94 degree angle. Check it out. Does your 94 plus your 66 add to the total 160 in your picture? Answer is yes. All right, our last example before you do these on your own has an exterior. One more time, we got some algebra to do, you can see. Exterior angle and 2 remote interiors, these two together. Okay, so let's just use our formula. I'm going to write the formula out on this one. So I've got exterior angle equals remote interior plus remote interior. Exterior angle is remote interior plus remote interior. Those are the ones I circled. So for the exterior angle, let's put in that 4 plus 16x. For remote interior, pick one of them. Just choose one. Let's take that 88 degrees. 88 degrees is one of them. Let's add to that. The other one is the 6x minus 4. So I'm just making those substitutions. And let's solve for x. All right, on this side, everything looks fine, nothing to combine. Over on this side, let's put that 6x in the front, and let's combine the 88 and that negative 4 to make that say just positive 84. Do you get the same thing? I'm just going to bring these down. Okay, now my x's, for the most part, they're over on the left side. I'm going to choose to keep them there. So let's take away the 4, because it doesn't have the x. Let's move it over here. And I'm going to subtract it from the 84 on the other side. Now on this side, I want my x's to leave. I want x's on the left side. So I'm going to take that 6x, and I'm going to subtract that from both sides. And let's see what we have. So 4 minus 4 wipes out. There's a ninja math right there. 16x minus 6x. That brings us down to 10x on the left side. And the 6x and the negative 6x. Yeah, those are gone. Ninjas wiped each other out right there. And 84 minus 4 is just going to give me 80. So 10x is equal to 80. And that means x, if I divide both sides by that 10, that'll bring me down to 1x. And so x is alone now as 8. Value of x is 8. Let's not stop there. Let's go check our question. Find the measure of DUV. So where is DUV? DUV is our exterior angle. So let's plug that value of x equals 8 into this angle right up here. So we're going to take 4 plus 16 times 8. 4 plus 16 times 8. Do the multiplication first. 16 times 8. 128. 128 plus 4 would be 132 degrees. And I'm not sure about my arithmetic on that. So I'm going to check my answer by also getting my remote interior angle here. So if I take 6 times 8 minus 4, substituting in this one, 6 times 8 is 48 minus 4 gives me 44. And does 44 add up with 88, the remote interiors? 44 plus 88, that's 132. That matches what I got for my exterior, so that checks. Awesome. Phew, that was rough. Hopefully you understood that, and give those try these some practice. We will check you tomorrow. Hopefully you do well.